Today we'll discuss ISI's B-Stat and B-Math 2013 paper, and the first question is, we are given the set S, which is sum of the series, which is iota plus iota square plus iota cube up to iota to the power n. Now this one result that we know is sum of any 4 consecutive powers of iota, it will always be 0. So if this n is a multiple of 4, in that case, we'll have k pairs having 4 consecutive powers each. In that case, this sum will be simply 0. Now, if n is of the form 4k plus 1, we'll have k pairs of 4 and then we're left with this one number. Sum of all these 4 pairs will be simply 0. This sum will be simply this iota. If n is of the form 4k plus 2, we'll have two remainders. We'll have s equals iota plus iota square, which is iota minus 1. And if n is of the form 4k plus 3, then s will be iota plus iota square plus iota cube. I'll cancel, and this value is minus 1. So there'll be two real values possible in this set, either 0 or minus 1, and that's your option B. Now here the question is, from the square of unit length, pieces from the corners are removed to form a regular octagon. Find the value of area removed. Now we have this square, and then we have removed 4 corners to form this octagon. The length of the side of the square is 1 unit. And suppose we have removed these triangles of length x unit. Now this is x and this is also x. So length of this side will be simply 1 minus 2x. Now we can also find length of this side. Length of this side will be simply under root 2x, and since it is a regular polygon, both the sides, they must be same. So from here we'll get x as 1 upon 2 plus root 2, or we can say 1 upon root 2 into root 2 plus 1. We can also write this as root 2 minus 1 by root 2. We need to find value of the area removed. Now value of this area removed will be 4 times area of this triangle. It will be simply 1 by 2 into x square, which is root 2 minus 1 square upon 2. Now this 4 will cancel. So this value will be simply root 2 minus 1 square, and that's your option D. Now this third question is, we define the dual of a line y equals mx plus c to be this point m comma minus c. Now it says, consider a set of n non-vertical lines n greater than 3 passing through the point 1 comma 1. Then the dual of these lines will always. Now any line which passes through this point 1 comma 1 can be expressed as y minus 1 equals m x minus 1, which we can write as y equals mx plus 1 minus m. Now dual of this line will be m comma m minus 1. Now let this x coordinate be alpha and y coordinate be beta. We can write beta as alpha minus 1, or it is x minus y equals 1. So dual of these lines will always lie on a straight line, and that's your option C. Now question 4 is, suppose alpha, beta and gamma are 3 real numbers satisfying cos alpha plus cos beta plus cos gamma equals 0 and sin alpha plus sin beta plus sin gamma equals 0. We need to find the value of cos alpha minus beta. Now what we'll do is, we'll write this as cos alpha plus cos beta, and it will be equal to minus cos gamma, and if we square it, we can write this as cos square alpha plus cos square beta plus 2 cos alpha cos beta, and it will be equal to cos square gamma. In the same way, from this second expression, we can write sin alpha plus sin beta will be minus sin gamma, and if we square it again, we'll write sin square alpha plus sin square beta plus 2 sin alpha sin beta, and it will be equal to sin square gamma. Now we'll add these two equations. Now cos square alpha plus sin square alpha will be 1. So 1 plus 1 plus 2. Now this is cos A cos B plus sin A sin B. So it will be cos A minus B, which is cos alpha minus beta, and it will be equal to 1. So we can write the value of cos alpha minus beta will be simply minus 1 by 2, and that's your option A. Now question number 5 is, we'll need to find the value of this limit, which is limit x tends to infinite 3 to the power x plus 7 to the power x to the power 1 by x. Now we know that a to the power infinite will be 0 if a lies between 0 and 1. So we need to express it in such a way that this a, its value will lie between 0 and 1. So we'll take this 7 to the power x common. So we can write this as limit x tends to infinite, it will be 7 and then 1 plus 3 by 7 to the power x whole to the power 1 by x. Now we'll put limit x tends to infinite, it will be 7 and then 1 plus will be 0 to the power 0, which is nothing but 7, and that's your option A. Now question number 6, it is a standard question which says distance between two foci of rectangular hyperbola defined by xy equals 2s. Now we know that this equation xy equals 2, we can compare it with the standard equation which is xy equals c square, value of c is simply root 2. Now for rectangular hyperbola, we know that the two focus, they are at root 2 comma c, root 2 comma c, and here will be minus root 2 comma c and minus root 2 comma c. We have already covered this in conic sections. I'll provide the link to rectangular hyperbola video in the description below. Now this point is suppose A and this is B. A in this case will be 2 comma 2 and B it will be minus 2 comma minus 2. Now distance between focus AB will be simply 4 square plus 4 square, and it will be simply 4 root 2, and that's your option D. Now question number 7 is, suppose f is a differentiable and increasing function on 0 to 1 such that f0 is negative and f1 is positive. So we have this function which is increasing between 0 and 1. And since it is continuous and differentiable, there will be some point, say alpha, at which this f alpha will be 0, where alpha lies between 0 and 1. Now let us talk about this function ft. Now we differentiate this function, we can write f dash t equals ft, and if we put it equals to 0, we'll get one critical point, and that is t equals alpha. Now we take this as alpha, this is plus and this is minus. So sign of derivative, it changes from minus to plus. That means alpha is a point of local minima. So this equation will have a unique local minimum in this interval 0, 1, and that's your option D. Now here the question is, in an isosceles triangle ABC, angle B is 120 degrees. The ratio of sides AC upon AB is. Now we have this isosceles triangle ABC, and this angle is 120 degrees. Now these two sides, they must be same. So this angle is 30 and this angle is also 30. Now we need to find AC upon AB. Now we can use sine rule. Now AC is proportional to sine 120 and AB is proportional to sine 30. So it will be equal to sine 120 upon sine 30. Now sine 120 is sine 60, which is root 3 by 2, and sine 30 is simply 1 by 2. So this value is simply root 3. So ratio of AC to AB is root 3 is to 1, and that's your option D. Now question number 9 is, let x, y, z be positive real numbers, and if the equation x square plus y squared square is equal to xy plus yz plus zx into sine theta has a solution for theta, then x, y and z must satisfy which of the following condition. Now if we take x square and y square, we can write x square plus y square upon 2 will be greater than or equal to xy using am and gm. In the same way we can write y square plus z square upon 2 will be greater than or equal to yz, and z square plus x square upon 2 will be greater than or equal to zx. Now we'll add them all, we'll get x square plus y square plus z square will be greater than or equal to xy plus yz plus zx. And the question it says x square plus y square plus z square, it is equal to xy plus yz plus zx into sine theta. So we put this value here, we can write xy plus yz plus zx into sine theta will be greater than or equal to xy plus yz plus zx. Now since x, y and z, they are positive numbers, we'll get this condition that sine theta is greater than or equal to 1. Now we know that sine theta is always less than or equal to 1. So this equation is possible if and only if value of sine theta is 1. So that means this theta, it should be n pi plus minus 1 to the power n into pi by 2. Now if sine theta is 1, we'll have this equality sign here. And if we have this equality sign, that means AM is equal to GM. And AM will be equal to GM if and only if the numbers are same. This equation is possible if and only if x equals y equals z, and that's your option A. Now question number 10 is, we are given sine theta and secant alpha, where theta lies in first quadrant and alpha lies in fourth quadrant. Then we need to find the value of sine theta plus alpha. Now if we write these basic angles, so this is theta, so this is 4, this is 5, and it is 3. And for the second one, it will be this alpha, this is 7, and it will be 4. 49 minus 16 will be simply under root 33. Now this is in first quadrant and it is in fourth quadrant. Now we need to find the value of sine theta plus alpha. Now sine A plus B is sine A cos B plus cos A sine B. Now sine theta, it is 4 by 5, and then cos alpha. In the fourth quadrant, cos alpha is positive, so it will be simply 4 by 7, and then plus cos theta is 3 by 5. Now here sine alpha will be negative, and it will be minus under root 33 by 7. So this value will be 16 minus 3 root 33 upon 35, and that's your option D. Now question number 11 is, Z1, Z2, Z3 be a sequence of complex numbers defined by Z1 equals iota and Zn plus 1 equals Zn square plus iota. Now we need to find the value of mod of Z 2013 minus Z1. Now if we put n as 1, we'll write Z2, and Z2 will be Z1 square plus iota. Now iota square is minus 1, so it will be simply iota minus 1. In the same way we can find Z3. Z3 will be Z2 square plus iota, and it will be iota minus 1 whole square plus iota, which is iota square plus 1 minus 2 iota and then plus iota. So here it will cancel. We'll get this value as minus iota. Now again, if we find Z4, Z4 will be Z3 square plus iota. Now Z3 square again is minus 1, so it will be iota minus 1. So for even index, we'll get Zn as iota minus 1, and for Z2n plus 1, it will be either plus iota or minus iota depending on the value of n. Now we need to find Z 2013 minus Z1 whole mod. Now we take n as 2012, we can write Z 2013 will be equal to Z 2012 whole square and then plus iota. Now iota is Z1. we can write Z 2013 minus Z1 will be Z 2012 square. If we take this mod, we can write Z 2013 minus Z1 will be mod of Z 2012 whole square. Now will be mod. Now when this number is even, it is simply iota minus 1. So mod of iota minus 1 will be under root of 2. So under root 2 square will be simply 2. So value of this expression will be 2, and that's your option C. Now here the question is, we need to find last digit of this number, 2 to the power 100, 5 to the power 100 and 8 to the power 100. We can write this as 2 to the power 100 plus 5 to the power 100 plus 2 to the power 300. Now if we look at patterns in powers of 2, 2 to the power 1, it is 2. 2 square is 4. 2 cube is 8. 2 to the power 4 is 16. And then again we'll have 2, 4, 8 and 6. So this last digit, it is periodic with the period 4. If we look at 2 to the power 100, we can write this as 2 to the power 4 to the power 25. So there are 25 cycles of these 4 expressions. So in this case, last digit will be simply 6. Now for any power of 5, 5 to the power 1 is 5, 5 square is 25, 5 cube is 125. This last digit will always be 5. Now for 2 to the power 300 also, we can write this as 2 to the power 4 to the power 75. Now again in this case, last digit will be 6. So if we add all these numbers, so it will be 17. So last digit in this case will be simply 7, and that's your option D. Now here the question is, find the maximum value of mod x minus 1 subject to the condition mod of x square minus 4 is less than equal to 5. We can write this as minus 5 will be less than equal to x square minus 4 less than equal to 5. Now it will be minus 1 will be less than equal to x square will be less than equal to 9. Now this is true for all x belongs to R. Now if we solve this, we'll get x should lie between minus 3 and plus 3. Now we need to find maximum value of mod x minus 1. Now we'll get this maximum value when both these numbers, they'll have the same sign, and this x, it takes extreme value. So the smallest possible value of x in this case is minus 3. So maximum value of this expression will be mod of minus 3 minus 1, which is simply 4, and that's your option C. Now question number 14 is, which of the following option is correct? We need to compare two functions, ex and e to the power x. So what we'll do is, we'll let function fx, which is ex minus e to the power x. And we'll consider this first case when x is greater than 1. Now if we find f dash x, will be e minus e to the power x. Now when x is greater than 1, it is less than 0. That means this f, it is a decreasing function. And if f is decreasing and if x is greater than 1, then fx will be less than f1. Now fx is ex minus e to the power x will be less than f1, and f1 is nothing but 0. So from here we get ex will be less than e to the power x. Now the second case, when x is less than 1, again if we write f dash x will be e minus e to the power x, and this case will be greater than 0 when x is less than 1. So f is an increasing function. Now if f is increasing, then fx will be less than f1, which is ex minus e to the power x will be less than 0. That is, ex is less than or equal to e to the power x. So in both the cases, whether x is greater than 1 or less than 1, ex is always less than e to the power x. And if we take x as 1, then both these expressions, they'll be equal. So answer to this question will be ex is less than or equal to e to the power x for all x, and that's your option A. Now here the question is, area of the regular polygon of 12 sides that can be inscribed in a circle x square plus y square minus 6x plus 5 equals 0. Center of this circle will be at 3, 0, and its radius will be under root of 9 minus 5, which is 2 units. So we have this circle of radius 2 units, and then we have inscribed a regular polygon of 12 sides. Now we consider any one triangle. This angle will be simply 360 divided by 12, which is 30 degrees. So this angle is 30 degrees. This is 2 and this is 2. We need to find area of this regular polygon. Area of this polygon will be 12 times area of this triangle, and area of this triangle will be 1 by 2, 2 into 2 into sine theta. Sine theta in this case is sine 30. Now this 2 and 2 will cancel. You get 24, and sine 30 is 1 by 2, which is nothing but 12. So area of this regular polygon will be 12 units, and that's your option C. Now here the question is, let fx equals under root log x base 2 minus 1 plus 1 by 2 log 1 by 2 x cube plus 2. The set of all real values of x for which fx is defined and fx is less than 0. Now what we'll do is we'll write this fx as under root of log x base 2 minus 1. We'll take this 1 by 2 as 2 to the power minus 1, and power of base, it comes out as a reciprocal. We can write this as minus 1 by 2. We'll also take this 3 out. So we'll write minus 3 by 2 log x base 2 plus 2, and we want this to be less than 0. Now what we'll do is we'll let log x base 2 as t. So we can write under root of t minus 1 will be less than 3 by 2t minus 2. Now since left hand side it is a square root function, its value cannot be negative. That means this right hand side, it must be greater than 0. So from here we'll get this condition that 3 by 2t minus 2, it should be greater than 0. That is t is greater than 4 by 3. Now considering t greater than 4 by 3, we know that both the expressions, they are positive. So in order to solve this inequality, we can square both sides. We can write t minus 1 will be less than 9t square by 4 plus 4 minus 6t. We'll write 4t minus 4 will be less than 9t square plus 16 minus 24t, that is 9t square minus 28t plus 20. It should be greater than 0. Now we can factorize this as 9t square minus 18t minus 10t plus 20 greater than 0. So it will be 9t minus 10 into t minus 2 will be greater than 0, which is 10 by 9 and then 2 plus minus n plus. So either the value of t is less than 10 by 9 or it is greater than 2. But then we also have this condition, t is greater than 4 by 3. So t is greater than 4 by 3. Now taking all the conditions together, we'll get this condition that fx is less than 0 when t is greater than 2. Now t is log x base 2. So we'll write log x base 2 is greater than 2. That is, value of x should be greater than 4. And that is the answer to this question. That's your option D. Now here the question is, let a be the largest integer, strictly smaller than 7b by 8, where b is also an integer. Now consider the following inequalities. 7 by 8b minus a is less than or equal to 1, and 7 by 8b minus a is greater than or equal to 1 by 8. We need to find out which of the following is correct. Now it is given that a is largest integer, strictly smaller than 7 by 8b. That means this a is greatest integer function of 7b by 8. And since a is strictly smaller than this value, that means 7b by 8, it is not an integer. Now if we look at 7b by 8 minus a, will be 7b by 8 minus greatest integer function of 7b by 8. So it will be nothing but fractional part of 7b by 8. Now we know that any fractional part, it is always less than 1. That means this statement 1, it is correct. Now what about this statement 2? Now we know that the 7b by 8, it is not an integer, and since we are dividing it by 8, we'll get this remainder as either 1 by 8, 2 by 8 up to 7 by 8. So the smallest fraction value for 7b by 8 will be simply 1 by 8. That means this 7b by 8 minus a, it will always be greater than or equal to 1 by 8. That means statement 2 is also correct. So the correct answer is this option C. Both 1 and 2 are correct. Now question number 18 is, we need to find this limit x tends to minus infinite. This summation k varies from 1 to 1000 x to the power k upon factorial k. So we have this limit x tends to minus infinite, and it will be x upon factorial 1 plus x square upon factorial 2 up to x to the power 1000 upon factorial 1000. Now if we consider this function, say fx, this function has even degree, and when the function has even degree, it starts from plus infinite. So that means when limit x tends to infinite, this function fx, it tends to plus infinite, and that's your option B. Now question number 19 is, for integers m and n, let fmn denote the function from the set of integers to itself defined by fmnx equals mx plus n. Now let capital F be set of all such functions fmn where m and n are integers. Now we call an element f invertible if there exists an element g such that g of fx equals f of gx equals x for all integers. Then which of the following is true? Now if we look at this function fmnx, we are given that it is equal to mx plus n. Now if we look at this condition, g of fx equals f of gx equals x, that means we are looking at inverse of this function. So if we have to find inverse of this function, we can write this as x, and it will be my plus n. Then we can write y as x minus n upon m. So this gmn x will be simply x minus n by m. Now if we take this composition, f of gx or g of fx, it will be equal to x. If m is 0, in that case, this gmn, it won't be defined. So that means there will be infinite elements which are not invertible. And if m is unequal to 0, we'll always have this g, which is x minus n upon m is defined. So answer to this question will be f has infinitely many invertible and infinitely many non-invertible elements, and that's your option B. Now question number 20 is, consider 6 players P1, P2, P3, P4, P5 and P6. A team consists of 2 players. Thus there are 15 distinct teams. 2 teams play a match exactly once if there is no common player. For example, teams P1, P2 cannot play with P2, P3 but will play with P4 and P5. Now we need to find total number of possible matches. Now for any match, we'll need 4 players, say Pi, Pj, Pk and Pr. Now first we'll choose this first team. Now in order to choose this first team, we need to choose 2 players from these 6 players, and it can be done in 6C 2 ways. Now we have to find number of ways in which we can select this second team. Now from these remaining 4 players, we have to select any 2 players, and it can be done in 4C 2 ways. So total number of such matches will be 6C2 into 4C2. Now 6C2 is 15 and 4C2 is 6, which is 90. But there is no option is 90. Now the problem here is, suppose we have 4 players, say P1, P2, P3 and P4. We can choose first team as P1, P2 and then the second team as P3, P4, or we can choose this first team as P3, P4 and the second team as P1, P2. So both these configurations they represent same scenario. So these two groups, when they interchange, they'll not result in a new configuration. So that means total number of possible matches will be half of this value, which is 90 by 2, and that is 45, and that's your option C. Now question number 21 is find the minimum value of f theta, which is 9 cos square theta plus 16 upon cos square theta. Now this cos square theta, it should lie between 0 and 1. So we can write this function as some function of t, where t is cos square theta. We write this is 9t plus 16 upon t, where t lies between 0 and 1. Now if we find f dash t, it will be simply 9 minus on t square. Now this value will be less than 0. That means this f, it is a decreasing function. If the function decreases, then its minimum value will occur at end of this interval. So minimum value of this function f theta, it will be when the value of t is 1. So it will be simply 9 into 1 plus 16 upon 1, which is 25, and that's your option A. Now question number 22 is we need to find number of zeros at the end of this integer, which is factorial 100 minus factorial 101 plus factorial 102 up to factorial 110. Now what we'll do is we'll take factorial 100 common, then we can write 1 minus 101 plus 101 into 102 minus 101, 102, 103 and up to 101, 102 and 110. Now we can find number of zeros at the end in factorial 100 by exponent of prime powers. So it will be simply 100 by 5 plus 100 by 5 square. So it will be 20 plus 4 and there will be 24. So in factorial 100 there will be 24 trailing zeros. Now we need to find how many trailing zeros are possible for this case. Now if we take this expression and let us say this is E, if we find this E modulo 10, then it will be equivalent to 1 minus factorial 1 plus factorial 2 minus factorial 3 plus factorial 4 minus factorial 5 plus factorial 6 minus factorial 7 plus factorial 8 minus factorial 9 plus factorial 10. Now all these factorials, they are multiples of 10. They will be divisible by 10. Now here 1 and 1, it will cancel. Now this one is 2, this is 6 and factorial 4, last digit is 4. So here it will be 6 minus 6, it is 0. So this expression E will be 0 modulo 10. So that means this expression, it is divisible by 10. Now what about divisibility by 100? So if we divide this E by 100, or we write E modulo 100, this value, it will be 2 minus 6 plus 24 minus 120 plus 720. We just need to write last two terms, 9 to 7, 40, 20, 80, and then it will be 0, 0, which is minus 20 and it is not equal to 0. So that means it is not divisible by 100. So in this expression E, there is only one trailing zero. So number of zeros in the end of this integer will be 25. That is 24 from this and 1 0 from this second expression. Now here the question is, we denote the largest integer less than or equal to z by greatest unit function of z. Consider this identity 1 plus x into 10 plus x into 10 square plus x up to 10 to the power 10 plus x. It is 10 to the power a plus 10 to the power b into x up to a11 x to the power 11. Now first we'll find the value of a. Now this 10 to the power a is its constant term, which is 1 into 10 square up to 10 to the power 10, and it'll be equal to 10 to the power a. So we can write 10 to the power a will be equal to 10, 1 plus 2 plus 3 up to 10, which is 10 to the power n plus 1 by 2, and it'll be simply 10 to the power 55. So value of a is nothing but 55. Now we'll find coefficient of x. So for coefficient of x, what we need to do is we just need to find this constant term leaving one bracket at a time. So this 10 to the power b, it will be, now we leave this one, it will be 10 to the power 55. Now we leave this 10, it will be 10 to the power 54, and it will go all the way up to this 10 to the power 55 upon 10 to the power 10, which is 10 to the power 45. Now this is 10 to the power 45 into 10 to the power. Now number of terms in this series, it is 11 minus 1 upon 10 minus 1, which is 10 to the power 45 into 10 to the power 11 minus 1 upon 9. Now since 10 to the power b is 10 to the power 55 plus some number, we can say that 10 to the power 55 will be less than 10 to the power b, and 10 to the power b, this value will be less than 10 to the power 45 into 10 to the power 11, which is 10 to the power 56. So from here we can say the value of b, it will lie between 55 and 56. Now greatest integer function of b, it will be 55. Now a is 55, that means greatest integer function of a is also 55. So the answer to this question will be greatest integer function of a will be equal to greatest integer function of b, while this b is greater than a, and that's your option D. Now question number 24 is number of 4 tuples ABCD of positive integers satisfying all these 3 equations a cube equals b square, c cube equals d square, and c minus a equals 64 is. Now cube of a is equal to square of b, so that means it is equal to sum n to the power 6. In the same way, cube of c is square of some number d, then it should be sum n to the power 6. Now if a cube is n to the power 6, we can write a as n square, and we can write c as m square. We can write c minus a equals 64 as m square minus n square equals 64. So it will be m plus n into m minus n, it will be 64. Now m and n, they must be positive integers, and they'll be positive integers when both of them either they are odd or they are even, but right hand side is an even number. So we have to express this as product of even numbers. So we can write this as 32 into 2, 16 into 4, and 8 into 8. Now we take this first case, m plus n is 32 and m minus n is 2, then we'll get 2m equals 34, value of m is 17 and value of n is 15. So we get one solution. Now for the second one, 16 and 4, we'll get m plus n is 16 and m minus n is 4. Now it'll be 2m equals 20, value of m is 10 and value of n is 6. So that's your second possible number. Now we take both of them as 8, then we'll get n as 0. Now we need positive integers, and not 0. So there will be only 2 such cases. So number of 4 tuples will be simply 2, and that's your option C. Now question number 25 is number of real roots of e to the power x equals x square. So we'll draw this graph. Now this is the graph of exponential function y equals e to the power x, and then we have to draw the graph of y equals x square. Now y equals x square, it is a parabola opening upwards passing through origin. Now here we have to make sure this graph of x square, it lies below the graph of exponential function. Exponential function, it increases more rapidly as compared to this polynomial function. So here on the right hand side, y equals x square, it won't intersect y equals e to the power x. In this case, this y is equal to x square, it will never intersect y equals e to the power x when x is greater than 0. So for this equation, there is only one solution, and that will be when x is less than 0. So number of real roots is 1, and that's your option B. Now question number 26 is, suppose alpha 1, alpha 2, alpha 3 and alpha 4, they are roots of the equation x to the power 4 plus x square plus 1 equals 0. So what we'll do is, we'll let x square as some y, we'll get y square plus y plus 1 equals to 0. Now we know that for this equation, roots are omega and omega square. So that means the 4 values of x will be plus or minus under root omega and plus or minus under root omega square, which is plus or minus omega. Now we need to find the value of alpha 1 to the power 4 plus alpha 2 to the power 4, alpha 3 to the power 4 and alpha 4 to the power 4. So alpha 1 to the power 4, alpha 2 to the power 4, alpha cube to the power 4 and alpha 4 to the power 4 will be under root omega to the power 4 minus under root omega to the power 4, omega to the power 4 and plus minus omega to the power 4. Now it will be simply 2 omega square and it will be 2 omega to the power 4. Now we can write this as 2 and this is omega square plus omega, and omega square plus omega is minus 1. So this value is simply minus 2, and that's your option A. Now question number 27 is, among the 4 time instances given the option below, when is the angle between the minute hand and the hour hand the smallest? So we are given time between 5:25 and 5:30. So we draw this clock, and then this is 5:30 and this is 5:25. Now first we will find this angle. Now this angle will be 360 divided by number of 5 minutes interval. Number of 5 minutes interval will be simply 12. So this angle will be simply 30 degrees. Now when the clock is at 5:30, our end, it will be exactly here. So this angle will be 15 degrees. Now for each 26, 27, 28 and 29, we have this value. So this is 526, 527, 528 and 529. Now we are not given 27, 28. So we'll discard this. Now we have to choose between 526 and 529. Now when the minute hand, it is less than 5:30, this R end, it will lie on this side of this dotted line. So in that case, the angle between this R end and 5:26 will be smallest. So answer to this question will be this option B, 5:26 PM. Now here the question is, suppose all roots of the polynomial px, a10x to the power 10, a9x to the power 9 up to a0 are real and smaller than 1, then for any such polynomial, this function, it is what? Increasing or decreasing? Now we find f dash x will be a10 e to the power 10x, a9 e to the power 9x up to a0, which is p as a function of e to the power x. Now when x is greater than 0, e to the power x, it is greater than 1. And the question, it says all the roots are real and they are smaller than 1. So if all the roots are real and less than 1, then after 1, this function will be either above x-axis or it will be below x-axis. So that means this Pex, it will either be always positive or it will always be negative. So this function fx will be either increasing or decreasing, and that's your option B. Now question number 29 is, consider a quadrilateral ABCD in xy plane. So we have this quadrilateral ABCD with all its angle less than 180 degrees. Now let P be an arbitrary point in the plane. So let there be this point P, and consider the 6 triangles, each of which is formed by this point P and 2 of the points A, B, C, D. So we have 6 triangles. So this is one triangle. This is another triangle. So we have 4 triangles, and then we have these 2 additional triangles with the diagonals. Now it says total area of these 6 triangles is minimum when this point P is. Now when we consider the area of all these triangles, then sum of areas of all these triangles, it will be area of this quadrilateral ABCD, and we can get this area considering P with AB, then P with BC, P with CD, and then P with AD. And then we'll also have this additional overlapping area. So when we have this area P with AC and P with BD. Now what is the minimum value of this overlapping area? Sum of areas of all triangle will always be greater than or equal to area of ABCD. Now we'll get this equality sign, that is this sum of areas will be minimum and will be equal to area of this quadrilateral ABCD when area of APC is 0 and area of BPD is 0. That means AP and C, they are collinear, and BP and D, they are collinear. That means this P, it must lie on intersection of AC and BD, and that's your option C. Now question number 30 is, graph of the equation, it comprises what? Now this is nothing but x plus y whole cube, and here if we take this minus sign, we'll get x plus y into x minus y equals 0. So we can get x plus y into x plus y whole square minus x minus y equals 0. So one of the curve will be x plus y equals to 0, and the other curve will be x square plus y square plus 2xy minus x plus y equals 0. Now this is nothing but it is a straight line. Now what about this curve? Now here value of a is 1, b is 1, c is 0, h is 1, g is minus 1 by 2, and f is 1 by 2. So if we find this delta, it will be 1, 1, 0, 1, minus 1 by 2, minus 1 by 2, and here will be 1 by 2 and 1 by 2. Now we take R1 minus R2, will be 0, will be 0, and this value will be minus 1. So this determinant will be minus 1 into 1, which is unequal to 0. So this equation, it doesn't represent a pair of straight lines. Now when it doesn't represent a pair of straight lines, we'll find h square, which is 1, and it is equal to AB. If h square is equal to AB, this equation, it represents a parabola. So graph of this equation, it comprises a line and a parabola, and that's your option B.